For 30 years, the Hubble Space Telescope stared at the ancient universe and told us a story. But it was looking at a ghost. Last year, James Webb made a discovery that rewrote that entire story, and it was hiding in plain sight the whole time. We thought we understood how the first galaxies formed. We were dead wrong. What James Webb found wasn't a new galaxy, it was a skeleton, the cosmic backbone that holds the universe together. And Hubble? Hubble was essentially blind to it. Here's what changed everything. For 3 decades, astronomers had a problem they didn't know they had. When Hubble peered at the most distant galaxies, looking back nearly 13.5 billion years into the past, it saw isolated islands, separate, scattered galaxies floating alone in the void. The math made sense. The universe was young. Gravity hadn't had enough time to weave galaxies together into structured networks. So astronomers built their models based on this picture. Galaxies forming randomly, then slowly clustering over billions of years. But here's the problem nobody saw coming. Hubble was using visible light. It was like trying to see a city at night with only a flashlight that can't penetrate fog. Most of the early universe is shrouded in dust, dust that visible light can't pierce. James Webb doesn't use visible light, it uses infrared. Infrared light passes through that dust like it's not even there. When JWST turned its infrared eyes toward the same patches of sky Hubble had studied, it found something impossible, something that shouldn't have been there. The skeleton Webb discovered was a web. Not a random scatter of galaxies, but an actual 3-dimensional filamentary structure, thin strands of galaxies connected like neurons in a cosmic brain. And it existed when the universe was only 700 million years old. That's only 5% of the age it is now. Let that sink in. Galaxies were already organized, already forming the same cosmic web we see today. But Hubble's visible light had missed the entire structure. Why is this such a big deal? Because it breaks our formation models completely. According to our best theories, galaxies should form through a process called hierarchical assembly. Picture it like this. You start with tiny villages, dwarf galaxies, which merge into towns, regular galaxies, which merge into cities, galaxy clusters. It takes time, lots of time. But JWST found that these megastructures, these cosmic filaments connecting galaxy clusters, formed far too quickly. The universe didn't have enough time for gravity to organize matter into these structures, and yet there they were. It's like opening your front door to find a fully constructed apartment building. You know it couldn't have been built overnight, but it's right there, fully assembled. Astronomers have a phrase for this, the early universe problem. And it gets worse. Webb found that everything formed earlier than predicted. The earliest galaxies are bigger than they should be. The first black holes are more massive than they should be. The universe at the dawn of time looks almost as organized as it does today. This suggests one of two things. Either our understanding of gravity is incomplete, or the Big Bang seeded the universe with far more structure than we thought. Maybe both. For the first time in 30 years, we have to ask, was Hubble right, or was it just missing the picture? The answer is it was missing the picture. So, what does this skeleton mean for us, for our understanding of reality? First, it means the universe is far more interconnected than we realized. Those filaments Webb found aren't ancient artifacts. They're the same structure we see today. Galaxies didn't organize randomly and then clump. They were born organized, connected from the very beginning. Second, it suggests the Big Bang wasn't as random as we thought. There's an asymmetry to the distribution of matter. Some regions got slightly denser than others right from the start. Those tiny variations rippled through space and crystallized into the cosmic web we see today. It's like the universe came imprinted with a blueprint. Third, and this is crucial, it means we need to recalibrate our measurements of dark matter and dark energy. If the early universe formed structures so quickly, either dark matter is behaving differently than we modeled, or there's missing physics in our equations. JWST isn't just finding new things, it's making us realize how incomplete our models were. Hubble showed us the universe, but it was showing us the universe through a straw, a limited window of the spectrum. This is why the jump from Hubble to JWST is revolutionary. It's not just better resolution, it's a completely different view of reality. And here's the mind-bending part. We're not done. JWST is just getting started. As it stares deeper and further back, we keep finding that structure exists where we predicted emptiness, organization where we predicted chaos. The universe appears to have been born organized, like it knew where it was going from the very beginning. We spent 30 years trusting Hubble's vision of a young, chaotic universe slowly organizing itself, but we were looking through fog the whole time. James Webb didn't just find a skeleton. It found evidence that the universe was designed with structure from the instant it began. And we're only starting to understand what that means.